So I can make up two questions based on this. First of all, let's see. I've got gas, 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 gas. So this is 3 gas and 5 gas. So I can make that a note to myself. So I'm saying just make up a question. And let's see. Decreasing H2S does what? Shifts the EQ equilibrium left because that's the weak side. You don't have to quote me, but I'm giving examples of answers I think are pretty decent. Decreasing H2S does what? Shift the equilibrium left because, oh, whoops, that's the weak side. Anybody need that repeated again? I don't know how much cursive interpretation it has fallen off. How about decreasing the volume does what? Quote marks means repeat from above. So I think that's the fast way to do that. If it's decreasing the volume, then there's a couple ways I could think about this, because I know I got better answers when I actually understood the point. So the more simple way is to say which side fits better into a smaller space, 3 gas molecules or 5 gas molecules. 3 does. So this will shift left because 3 fits in there better than 5. Another way that I got into explaining this in period 4, I think, somebody who was actually really interested, so in case this helps, is this one. This one's got to make 3 things meet together to react. This one's got to make 5 things meet together to react. Which problem sounds harder to do? Having 3 things meet up at the same time or 5 at random? 3 at random versus 5 at random, right? 5 is harder. Okay, so if I cram these together better, I'm helping both sides meet up, but I'm helping this side by a bigger percentage than that side. This side needs more help. And when I help them out sort of equally by cramming them together in the same space, by percentage, this one gets, say, let's just make up a number, 20% better, and this one only gets 5% better, or something like that. So this side gets helped out more, but that means that it does a better job of doing its job, and its job is to make the other side. So this one gets helped out in its job better than that one, which means actually it goes left, because when this one does its job, it makes the left side. When this one does its job, it makes the right side. So either way you want to look at it, it shifts left. And I keep saying the great thing about reality is it doesn't have plot loopholes. Like even the non-superhero movies, a lot of times, if you really sit there and think about it for an hour, you can say, wait a minute, that doesn't make any sense, because then they would have done this thing, because the script writer just kind of hoped you wouldn't notice, right? But reality doesn't have plot loopholes. You can look at it this way or that way or this way, and you get the same answer. So it will shift equilibrium left. That's actually the same answer, so I guess I can use quote marks. Because it has fewer gas molecules. I'm going to try to fit this on one line. I should have started farther left. How about that? We'll use an abbreviation and come up before the edge of the paper. So decreasing the volume does what? Shifts the equilibrium left because it has fewer gas molecules. Online people, should I repeat something? I don't see a chat. I am trying to pay attention here, but I can't make it go ding. Number 2, can somebody suggest a question? I can see Josh here paying a lot of attention. That's a compliment, Josh. Can you throw me one? Increase, decrease, volume, pressure, temperature. Well, we can't do temperature because we don't know where the heat is. Let's take temperature out for number 2. Decrease volume. Decreasing volume does what? And let's see, I got to count my gas molecules, right? Gas, gas, gas. Okay, so 3 gas and 2 gas. So it will shift the equilibrium left again. Now, just in case somebody is only half paying attention, decreasing volume does not always go left. And that's why I'm having us write out the answer. Why? Not because it's left, because it has fewer gas molecules. What was the one I was thinking of an example. People get the wrong idea. Oh, when we do the polarity, I get kids who kind of only come back mentally halfway through and they say to themselves, oh, polarity arrow goes always goes away from the cloud, the unshared cloud. No, that's not how it works. Sometimes it goes toward the cloud. So I'm trying to make it real clear. Decreasing volume does not go left. It goes the direction of the fewer gas molecules. So left this time again, but because it's not a good S, it has fewer gas molecules. I got to start these farther left again. Whoops. Also, I misspelled that. Decreasing volume does what? It will shift the equilibrium left because it has fewer gas molecules. Can you suggest, Jessica, can you suggest a question? Can't do it. Jesse, can you suggest one? Increasing SO3 does what? Shifts the equilibrium right. Now, you could say this one of two ways, either because the right is the weak side by comparison, or the left is the strong side by comparison. They're kind of saying the same thing. So I don't really care to argue about it, because how about left is the strong side? Just because last time I said weak side, so this time I'll say strong side. So increasing SO3 does what? Shift the equilibrium right, because left is the strong side. And I'm very deliberately trying to make people think through and explain why, because otherwise this unit gets really shortchanged. It gets really, really quick. People just draw arrows and then they kind of stop thinking. I put up solutions, they just draw arrows and then they don't know why. And I think it's one of our easier units, but I think people stop really paying attention to the reasons. And then when I give them a quiz, I get, same normal kind of scores, which means a bunch of people don't do very well. And I think it's because they stop paying attention, because it can't be hard, it's arrows, duh. Well, yeah, but you do have to get the point. So when I change the questions, you got, a way to get the right answer. I'm going to do at least one more here, and I'm going to very definitely include the heat in this. So this is this explanation is on the front of that first one we did from last time. If it's got a plus sign here, if it's a positive value, or even if it doesn't have a plus sign, as long as it doesn't have a negative sign, the heat goes on the left. So the heat goes over here. And by the way, that's called endothermic. You don't actually have to put this for the answer, but in case that helps, because the heat is going into the chemicals. And so, let's see here. I think I want to say decreasing the temperature, because this one is the one that kids get wrong more often. Decreasing the temperature does what? And it will shift equilibrium. Well, tiny mental self quiz. You don't have to shout out an answer, but what do you think? Left. Because if you think of this as a reactant, as almost like a chemical, if we decrease this, we're like disempowering the left side, which means this is the weak side for a moment. That's the strong side by comparison for a moment. This does a better job than that side does. And what does this side do? It makes the left. So we're making more left than we are right for a moment. As long as you keep doing this, basically about as long as you keep decreasing the temperature. Because that's the weak side. Should I repeat something or read something off, online people? I'm just saying I can read it again, so I don't need any excuses about I couldn't read it, because I'm asking you to ask again. I can read it again. I can say it again. But we did decreasing volume. How about this? Decreasing pressure. Does what? And here's the thing to remember, maybe put a note up here. If the volume goes up, the pressure goes down. And if the volume goes down, the pressure goes up. I would suggest note to self. In fact, here, just make sure. There, those are separated like that. So if the pressure goes down, decreasing means the volume goes up. And so we could think about it two ways. Which side fits into a greater volume better, the 7 gas molecule side or the 2 gas molecule side? Well, the 7 does. So we get the answer that it will shift right. Also, in case this helps, remember when we said decreasing the volume helps out with the greater problem? Well, getting 7 things to meet is a lot harder than 2 things. So if I cram this all together, I'm helping this side out a lot more than that one. And then somebody's shouting in their brain, but you said the opposite. You said the volume's going up. Right. So let's do the opposite. And if you do the opposite, you get the opposite. So let's expand that. Well, you heard them. Yes, right. But I heard that one more. If shrinking it helps this side, the 7 molecule side more, then expanding the balloon hurts that one more. And so this side is the weak side as I expand the volume, the balloon, or the size in the cylinder. Either way you want to look at it, we get the idea that it's shifting right. And I'm going to use the weak side, strong side argument. If I expand the balloon, I hurt the greater gas molecule side more. So that's the weak side. So it will shift right, equilibrium right. Because it has more gas molecules, or it's the weak side. Whichever side, whichever explanation really helps you more. Would someone like to make a request of one of these or read me off their question that they tried on their own, that they made up?